Hi everyone, today I would like to discuss with you what is a wave and how to derive the equation of a traveling wave. So the first question is obviously what is a wave? So imagine there is a surface of water here. Okay, so this is a surface of water. It is calm, so no wind is blowing. And on this surface there is a plastic ball which is floating. Now, if I disturb one part of the water like this on the surface, then you will see after some time the ball will also get disturbed. So meaning whatever disturbance you created on this part of the water, that disturbance slowly propagates and then reaches the plastic ball. That's why the plastic ball also got disturbed, isn't it? So this is what is an example of waves. So a wave is a propagation of disturbance, but there is no transfer of matter, remember. So matter is not getting transferred. The water itself did not go from here to here, right? So the water did not go from here to here. What went from here to here is the disturbance, or you can say energy, right? So if they ask what is a wave, what we should say? A wave is a disturbance which propagates forward without any transfer of matter. So the matter is not going to transfer. What is getting transferred if they ask? Well, energy is getting transferred. Let me give you another example. Think of this string, a very long string, and one end you hold the string and the other end is very far. Okay, imagine it to be very far and fixed it on the wall. So this is a wall. Now why I want this to be very far? Because if this is very near, then what will happen? Whatever wave I create here, that will be reflected from the wall. So that I don't want to discuss right now. So right now I want to talk about traveling wave, not about what happens when traveling wave and reflected wave will overlap, isn't it? So if there is a wall, there will be a reflected wave, and that reflected wave and this incident wave may overlap. That I don't want. If that happens, we get something called standing waves. But let us not worry about standing waves right now. So imagine this wall is very far. Now, what you do, take this end of the string and disturb, create some kind of disturbance. Let us see how the string looks as I oscillate this point up and down. So the first time when I do like this, how the string will look? Let me show it down here. So it will look something like this, right? So this is the part when I move this point up. Now, because these small parts of the string, they exert force on each other. What is that force called, if you remember? Tension, right? So the tension is the force between different parts of the string. So because of interaction between the string, when this part goes up, as you can see, this will pull this one up. This will pull this one up. So after some time, what will happen? This part will go up. But by that time, what your hand did, your hand is coming back, isn't it? So you went up and then you are coming down, right? So as you come down, this part will pull this part up. So your string will look something like this, right? Now, as this has reached here, whatever happened here, same thing will happen here now. This part will pull this part up. And by that time, this end will go where? It will go below this line, right? Because you are going to move this up and down like this, right? So after some time, this part will go down. So the string will look something like this, isn't it? Now what will happen? This part will pull this part up. So this part will go up like this. And by this time, your hand here will come back to the old position, isn't it? Right? So your string will look something like this, right? So what happened from here to here? If you look carefully, you created one full cycle, and this distance is what we call wavelength. This is called wavelength. So if you look carefully, whatever disturbance you created here, that has reached here after some time, then that has reached here after some time, that has reached here after some time, right? This part is going to pull this part up. So it should have been something like this, right? So whatever disturbance is created here, or you can say displacement, isn't it? If I say this is y-axis, then this is displacement, right, along y-axis. So this displacement, you can see, propagates forward, and that is something very important to remember. So during wave propagation, this disturbance will propagate with a definite speed, right? And that you must remember, because the derivation of equation of traveling wave is based on this concept. Which concept? Whatever disturbance was created here will reach here or here after some time, right? Now, from here to here, what time it took, let us think. So this was the position of the particle. Then from here it went up, right? This one. Then it came back here. Then it again went down. Then again it went up, right? From here to here. So this is one oscillation, right? This way, right? So one oscillation, the time taken is called time period, isn't it? So during time equal to time period, when the time equals time period, you can see the disturbance traveled from here to here, isn't it? So this disturbance which was here reached here. That's why this one has reached here, isn't it? So how much distance it traveled? The disturbance traveled a distance x equal to lambda. So distance traveled is lambda in what time? Capital T time. So during that time my hand went from here to here to here. I created one cycle, and the distance covered in one cycle is what is called wavelength. And remember, who is covering this distance? This distance is covered by the disturbances, not by the particles in this direction. Particles are not moving in this direction. Particles are simply moving up and down. What is moving forward is the disturbance, or you can say energy. So, distance covered by the disturbance is lambda, and time taken is time period. So, what will be the speed of the disturbance? Speed of the disturbance, that will be equal to distance by time. Distance covered is lambda, time taken is capital T, and this speed of disturbance is nothing but velocity of the wave. So this is also called wave velocity. So wave velocity v is equals to lambda by t, and 1 by time period is called frequency. So this is the relation between velocity, frequency and wavelength, which can be easily derived by understanding this concept, right? Now we will derive the equation of a traveling wave, also called progressive wave. So for deriving this, very simple it is. Imagine there is a string which I keep along x-axis. Now I will create disturbance of this point in this fashion. Like this, I will move up and down, and you know what will happen, right? A wave will be created, as I have shown you before. So I will create the disturbance along y-axis. So let us say this is your y-axis. Now if you take this point as origin, x equal to 0, and if you move this point in this fashion, and let us assume this point is moved in a simple harmonic way. When I say this point is moved in a simple harmonic way, it means the displacement of this point can be written as equal to a sine omega t. So this is the equation of displacement of a particle performing simple harmonic motion. This is done in the previous chapter, oscillation. If you want me to derive this, let me know in the comment section. But this you must know. So this is the displacement of which particle? Particle at x equal to 0. So let us try to show it in the form of a function. So let us say displacement of which point? X equal to 0. At what time? At time t is given by what formula? A sine omega t. Why this formula? Because I am moving the particle in a simple harmonic fashion. And why I wrote this way? So that you know that this is displacement of not any particle here. This is displacement of particle at the origin. At what time? T time. Now, you know from the previous concept that whatever displacement or disturbance you create here, that will travel forward, that will reach here after some time. So if I want to know what is the displacement of not this particle, which is at the origin, but if I want to know displacement of this particle, let us say this particle name is P. So if I want to know displacement of this particle which is at a distance x, then I want to know what is the displacement y of this particle which is at which position x. At what time I want to know? T time. Then that should be equal to how much? Now to understand this, listen carefully. If you remember the previous example which I told you, whatever disturbance you create here, that will reach here after some time, isn't it? So let us say I create disturbance here at time 10 a.m. At what time I created disturbance here? 10 a.m. Now that disturbance will travel with some speed. Let us say the speed is v. V is the speed of the disturbance, or you can say speed of the wave. Now, for this disturbance to reach here, how much time it will take? Time taken. When you know distance and speed, how do you calculate time? Distance divided by speed. Right? Speed is distance by time. So if you cross multiply, time will be distance by speed. This is time taken, remember, by this disturbance to reach here. Let us say this time taken is 30 minutes. Obviously, it will travel very fast. But for example, I am writing 30 minutes. So if this disturbance, x equal to 0 disturbance, remember, given by this formula. So if this disturbance or displacement was created at 10 a.m. and it took how much time for disturbance to reach here? 30 minutes. Then this disturbance will reach here at what time? 10:30 obviously. Right? That means if you want to know displacement, this displacement, or right now I'm calling it disturbance also, right? So if you want to know displacement of this particle at what time? 10:30. Then that disturbance was created here. At what time it was created? 10 o'clock. So students, if I want to know displacement of this particle at time t, that same disturbance will be here before. At what time? 10 o'clock. That means I can write, if this time I am writing as t, then this time I can write as t minus x by v. Isn't it? Try to think carefully. If the time here I am writing as t, if I want to know disturbance here at time 10:30, then that disturbance was created here at what time? 10:30 minus 30 minutes. Matlab x by v. This is the time taken. So the displacement that you want here at what time t was same here at what position? X equal to 0 at what time? Not t, because it was done previously. So t minus x by v. So this is the equation you guys must understand. So how to write this in words? Displacement of point x at time t was created here. Matlab whatever was created, same is reaching here. Same only is reaching, right? So it must be equal. So whatever displacement here you want, x at position x, that was created here. So displacement at which position it was created? X equal to 0 at earlier time or later time? Obviously earlier time. What time it must be? If you are measuring this displacement at 10:30, then this time must be 10:30 minus 30 minutes. So you are measuring this displacement at time t, then this displacement should be measured at what time? t minus x by v. Is it clear or not? Now, we already know formula for displacement of particle at x equal to 0. This is the formula for what time? T. So if I want for t dash time, what will you do? T dash. If I want for time t naught, what will you do? T naught. If I want for what time? T minus x by v, then what will you do here? T minus x by v you have to substitute. A sine omega. This is the formula at time t, but we want at what time? T minus x by v. So in place of t, you have to substitute t minus x by v. Then you can open this bracket, a sine omega t minus, put this omega inside, omega by v into x. And this ratio, we write it as k. What is this k? We will discuss later, but just write this ratio as k. If you want to keep it like this, also no problem. But if you write this like k, the equation looks nice. So it will be equal to a sine omega t minus kx. So what did you learn? Something very important. If there is a minus sign here, it means the wave is traveling this way, isn't it? Because first this wave will be created, then this wave will be created. So whatever disturbance you created here was created here at an earlier time. That's why minus sign is there, isn't it? So that minus sign will be here also. So please remember, if there is a minus sign here, the wave is traveling this way. What if the wave was coming this side? In that case, what will happen? If this happened at 10 o'clock, this will happen at 10:30, isn't it? So if you want to know displacement at what position, x position, at what time, t time, then that will be created later here. At what time? 10:30, matlab it will be t plus x by v. So you have to put here plus, you have to put here plus. So when will you put plus? If the wave is traveling this way, not this way. Okay. So a wave traveling along positive x-axis will have a minus sign, and a wave traveling along negative x-axis will have a plus sign. Right? Now let us try to derive the relation between phase difference and path difference. But before that, you should be knowing what is phase. Now, whenever something oscillates or vibrates, to know its condition here means to know its state of vibration, you need to know two things. One is where is the particle, and second thing, where it is trying to go. Where it is trying to go means what? You should know its velocity. So if you know the position of the particle and the velocity of the particle, then you know the state of the particle. That is given by something called phase. For example, when I told you, when a particle moves up and down along y-axis, then the displacement at any time is given by what formula? A sine omega t. Of course, when I write this formula, it means at t equal to 0, y was equal to 0. Because if you put t0 here, what will you get? Sine 0 is 0. That means when the particle is here, I started the watch. Matlab my time 0 started when the particle was here. So as the particle is going up and down, when it is here, I started my watch. Some of you can also write y equal to a cos omega t. No problem. But if you write this, then it means what? At t equal to 0, y will be equal to how much? Put t equal to 0. Cos 0 will be 1, so y will be a. That means if you write this function, then it means you started your watch when the particle was here, not here. So that doesn't matter, right? That initial condition doesn't change the fact that the particle is performing simple harmonic motion. So this equation can also be used. This can also be used depending on where the particle was when you started the watch, right? Now this quantity, whatever is after sign, that is what is called phase. Why this is called phase? Let us try to think. If you know this phase, let us say at some time you know this value. Now this value will be always as an angle, because sine of 40 kg nobody will ask. Sine of 45 degree, yes, it is correct. But sine of 45 kg is wrong. So this must be some angle only, right? It must have units of radian or degrees. So let us say this is right now 0 degree. So if this is 0 degree, what will be y? A sine 0. A sine 0 means 0. So you know the particle will be here. Then taking velocity dy by dt, you can find the velocity also, right? Similarly, if this angle was 90 degree, what will be y? A sine 90 degree. A sine 90 degree matlab A. You will know the particle is here. What if this was, let's say, 30 degree? Then sine 30 degree will be half. That means y will be what? A by 2. The particle will be here. So this way, by knowing this angle, you will know where the particle is. And that is why we say this angle represents the state of vibration. So phase basically determines the state of vibration, where the particle is and where it is going to go. So for example, if I move my two hands like this, so we say they are in same phase because you can see both of them reach maximum together, both of them reach zero together, both of them reach negative maximum together, right? So this means they are in same phase. What if I do like this? When this is positive maximum, this is negative maximum. That means the phase difference is 180 degree, isn't it? Why? Y1 equals to A1 sine omega t, let's say, for some particle. And for another particle, it is Y2 equal to A2 sine omega t plus 180 degree. Now look carefully. When omega t is 90 degree, meaning this omega t is 90 degree, what will be the value of Y1? Check. When sine 90 degree is 1, so Y1 will be A1. What about Y2? When omega t is 90 degree, when this is 90 degree, 90 degree plus 180 will be 270. Sine 270 is minus 1. So Y2 will be minus A2. So this will reach negative maximum. This will reach positive maximum like this. Are you clear? The values may not be same. See, this could reach positive maximum up to here. This could reach negative maximum up to here. But it should be at the same time. Like this. Right? So if they are moving this way, when one is reaching positive maximum, other is reaching negative maximum, then we say there is a phase difference of 180 degree. And what if I do like this? When one is 0, other one is positive maximum. And when this one becomes 0, this one becomes negative maximum. Like this. That means their phase difference will be 90 degree. You can check. How you can check? Look carefully. When omega t is 90, what will be y1? A1, right? Sin 90 is 1. When this is 90, what will be 90 plus 90? 180. So sin 180 is 0. So if the phase difference is 90 degree, you can see this is omega t, this is omega t plus 90. So if the phase difference is 90 degree, it will be something like this. Okay. So when one is 0, other is positive maximum. So then the phase difference is 90 degree. Now let us find the relation between phase difference and path difference for a traveling wave. So we have seen that for a traveling wave, the equation is A sine omega t minus kx. Right? Now, if you want to write this formula this way, A sine kx minus omega t. This is also allowed. The reason why this is also allowed is because just because there is plus sign, don't think that this will be always plus, because there is a sine function and time is here. X is also here. So as you change time, and how do you change time? You just wait and watch the waves. So as the wave moves, as time changes, this whole angle will change, na? And when this angle will change, sine of angle will keep becoming 0, 1, 0, minus 1. So sometimes this will be minus also. There will be some moments when this y will be minus. So at that moment, if I write the equation, you cannot say it is wrong. And if this is minus, you can put this minus inside and then interchange these two. So if this is right, this is also right. Okay. Now let us assume this is the direction in which the wave is traveling. Let us take two positions x1, x2. So I have two particles here, particle number 1, particle number 2. And this difference in the distance between them, the gap between them is what is called path difference, delta x. So delta x represents the path difference. Now when x is x1, what will be your phase? This is your phase, remember, for a wave, for which I can write the symbol phi. So what will be phase when x is x1? It will be omega t minus kx1. Please remember, I have chosen the time to be same. So at same time, I am looking at the phase of two particles. Let me repeat. At same time, I am looking at the phase of two particles. So one particle's position is x1, put x1. That will give you phase of the first particle. Phase of the second particle will be omega 2 minus kx2. If you see the positions, I have chosen x2 more, right? So if x2 is more, minus, if you subtract more, you will get less. So this will be more than this. So phase difference delta phi will be, this will be bigger. Why this will be bigger? Because x1 is less. If you subtract less, you will get more. So phi 1 minus phi 2. If you substitute this phi 1 here and phi 2 here, what will you get? Omega t minus kx1 minus phi 2 you substitute. Omega t bracket minus kx2. Now omega t minus omega t will cancel. So you will get minus kx1 minus minus plus kx2. So phase difference will be kx1 minus, sorry, this is minus kx1 plus kx2. Then if you take k common from here, you will get x2 minus x1. And this x2 minus x1 is your path difference. So what is the relation between phase difference and path difference? Simple relation. Phase difference is k times path difference. Okay. Now, let us write k in terms of wavelength. If you go back and check the derivation of equation of traveling wave, I wrote k in terms of this ratio, omega by v. So sometimes if you know k and omega and they ask you to find v, what will you do? Cross multiply, v will be omega by k. So this is easier way to find v if you know omega and k. Now this k, now what was the formula for omega? 2 pi divided by time period. And velocity formula was frequency into wavelength. Now 1 by time period is also frequency. So frequency cancel. So k can be written as 2 pi by lambda. Isn't it? So just like if you remember 1 by time period, what is this? Frequency. And what is the meaning of frequency? Number of oscillations, or you can say number of waves per second. Isn't it? So if 1 by time period is number of oscillations per second, what will be 1 by wavelength? It will be number of oscillations per meter. Right, per meter, because this is wavelength, this is time period, right? Now if you multiply this with 2 pi, then that is what is called omega. And 2 pi, the moment you do 2 pi, what will happen? It will become number of oscillations, but in what units? If you multiply by 2 pi, it will be in radian. So number of oscillations in radian. Similarly, if you multiply with 2 pi, it becomes number of oscillations in radian per meter. So this is your k. So if somebody will ask you what is k, what you should say? The number of oscillations, or you can say number of waves per meter in 1 meter. Okay. In what units? Radian. This will have units of radian per meter, right? This will have units of radian per meter. This will have units of radian per second. So since this gives you number of oscillations or number of waves per meter, in 1 meter of space, in 1 meter of space, not in 1 second of time. Okay, don't confuse with this and this. So number of cycles in 1 meter of space, that is what is called wave number. So that's why this k is also called wave number. Actually, it should be called angular wave number, because you are multiplying with 2 pi, so it becomes angular wave number. Just like this is called not frequency, this is called angular frequency, right? Let us now see a simple problem. Imagine this is the wave equation, y equal to 10 sine 100t minus 20x plus pi by 4. Now, here they told this x is measured in what units? Meter, and y is measured in what units? Centimeter. Sometimes both will be in meter, but I thought let me change it so that you guys will be able to answer both. So if x is given in meter, now look carefully, if this is given in meter, then if you remember units and measurement chapter, then we know that sine cannot have any unit. Sine is a dimensionless quantity, isn't it? Sine function. So since this cannot have unit, if x is in meter, then this 20 must be in what unit? 1 by meter, isn't it? So that when you multiply this, meter cancel. So please understand, this 20 is not just number 20. It is 20, but in what units? Per meter. How I know per meter? Because x is given in meter. So this 20 must be in per meter. What about this 10? Well, if this has no unit, y and 10 should have same unit. Left side and right side should have same unit. So since y is in centimeter, this 10 will be also in centimeter. What if y was in meter? Then this 10 also will be in meter. And what about this t? T is in, they have not mentioned, so we will assume t is in seconds. Now, if t is in seconds, then this 100 will be in what units? 1 by second. Don't forget this, okay? So let's start. So to answer this question, the first thing you should write is, first you should write the standard equation. So standard equation of a traveling wave, y is equal to a sine, and if they have given t first, then write t first, omega t minus kx. Sometimes they will write this one first, then you write here kx minus omega t. I told both are correct. Now here one thing you notice, they have given this angle here also, extra. So put here some extra angle, phi. This phi is called epoch. Now what is this epoch? This epoch basically gives you the phase, right? This is the phase, isn't it? Now if I ask you what will be this phase at t equal to 0, for which particle? At x equal to 0. So for particle at origin at time 0, what will be this phase if I ask? What will you tell? It will be 0, 0. If you put this whole thing will become what? Phi. So phi is nothing but initial phase. Initial means at t0. For which particle? X equal to 0 particle. So phi represents the initial phase of particle which is at x equal to 0. At what time? T equal to 0. If you now compare this standard equation with the given equation. So given equation also you can write in exam. So now by comparing, what will be the amplitude? The first thing is amplitude. You can see the amplitude is in front of sine function, that is 10. In what units? Remember, centimeter, because y is given in centimeter. So don't blindly write meter. Okay. What about part 2? Wave velocity. Now, if you compare, but first let me do a comparison. So by comparison, amplitude we found. Also, by comparison, this omega will be how much? 100, right? In what unit? Per second. And k in what unit? Is 20 per meter, isn't it? So what was the wave velocity? If you remember, I told you, if you know omega and k, directly wave velocity you can write omega by k. So 100 by 20, that will be 5 meter per second. Why meter came in numerator? Because this 100 is per second and 20 is per meter. So meter will go in numerator. That's how the units will come nicely. Then this part is over. Wavelength. Now wavelength is hidden in the formula of K. So K, third part, K we wrote 20 per meter. Now what is the formula for K? I wrote 2 pi by lambda 20. So from here if you cross multiply, lambda will be 20 will come here, lambda will go here. So 2 pi by 20. And since this 20 is in per meter, when you cross multiply, meter will come here. So whatever number comes, that will be in meter, remember. So wavelength is done. Now frequency. To find frequency, you have to think of omega. Omega equals to how much I wrote? 100 per second. So omega is 2 pi divided by time period. 1 by time period is frequency. So frequency will be 100 divided by 2 pi. In what units? It will be per second, right? Because this 100 is in per second, and that per second is also hertz. So 50 by pi hertz. You can divide 50 by pi. And then phase of x equal to 0 at t equal to 0 means epoch only I told. If you put 0 here, 0 here, this is called phase, right? So phase, if you want to know for x equal to 0, origin particle, initial if they say means what? T is 0. Then what will be the phase? Phi, and that is given pi by 4. So the last part, number 5, let me show here. Number 5 will be phase at t0, x0 will be pi by 4. So this way we can easily solve the problem, right?